Action. Hello everyone and welcome back to the Techverse YouTube channel. In today's video we are tackling the latest questions from the TCS IPA 2026 exam and we will be solving them using Java streams. Even if you feel your Java skills are a bit weak, don't worry at all. I've broken everything down so clearly that you'll be able to follow along and understand every single solution perfectly. Today we are covering two major questions from the exam. 1. A geometric progression (GP) question worth 15 marks. 2. An object-oriented programming (OOP) question worth 35 marks. Let's dive right into the first question. Question 1. Geometric progression, 15 marks. For the first problem we are given 3 input digits to perform a geometric progression. I'm sure most of you are already familiar with how a GP series works, but just as a quick refresher, I am displaying the GP progression formulas right here on the screen for you to check out. Here is the exact algorithm we need to follow. First, we take 3 numbers as input. The first number is our initial term, let's call it a say. Second, A, we take the number of GP terms required, N. Keep in mind a critical edge case here. If this term is given as 0, we must print a specific error line. Third is, we take the common ratio, R. To generate and print the GP series, we repeatedly multiply the initial term by the common ratio. Now let's look at the screen where the Java stream solution is displayed. As you can see, we use the stream to elegantly generate the series up to n terms. Check out the code carefully to see how cleanly Java streams handle this logic. Question 2. OOP and association, 35 marks. Now let's move on to the second question, which is a classic TCS IPA 35-mark OOP problem. The problem statement asks us to create a bank account class. Remember a golden rule for these exams: attributes, or variables, must always be private, and we access them using getters and setters. We also have a KYC class with its own private attributes. The problem specifies that each bank account should contain only one KYC dense. This means KYC is not independent, it strictly depends on the bank account. Even though the question text doesn't explicitly say the word association, this relationship is the exact definition of aggregation in Java. Let's look at the implementation. To perform aggregation, we include a KYC object as an attribute inside our bank account class, like this line here. Next, we create our solution class. In the solution class, we are asked to implement a method called findBankKYC. Here are the key requirements for this method. 1. It must perform a case-insensitive search, meaning cat and cat will be treated as the exact same thing. 2. The core condition to check is whether the KYC status is lapsed and if the occupation matches the input. 3. If no elements match these conditions, we must print KYC not matched and return null. If elements do match, we will return the filtered array. To handle the resulting array dynamically without a fixed size, we can declare a Java array and use arrays.copyof to dynamically clone and increase its size as we find matches. Finally, in the main method, we take the user inputs, pass them to the setter methods, and invoke our logic. Take a look at the complete solution displayed on the screen right now. And yeah, outro. That is the complete optimized solution for the TCS IPA 2026 questions using Java streams. If you have any questions, confusion or doubts about the logic or the stream syntax, please drop a comment down below.